All right, so what about this one? Now, this one says a scientist begins with 100 milligrams again of a radioactive substance, so maybe like the radon 222. But this one and it decays exponentially too. But this one doesn't give us the rates and all those things. It gives us, well, after 35 hours, we only have 50 milligrams of this substance remaining. So it wants to know how many milligrams remain after 54 hours. Okay, well, we know after 35, but now we need to find 54. So that means we actually have to figure out some things here. So what do we know? Well, at T of 0, we have how much? Well, we have 100 milligrams. So that's kind of our point 0, 100. Okay, well, hey, that gives us an A value, right? So that's a start. What else does it tell us? Well, after 35 hours, we have 50 milligrams. So 35, 50. So guess what? We've got 2 points, and now we need to find our B value, or basically our R value, because that's what we're going to look at. Because now we have, instead of a B, we're using this going to be decaying in a certain way. So let's write this out. So we're going to have 50, that's our y, equals A, which is 100, and it's exponential with the e exponential, and it's going to be to the power, and now this is going to be r. We don't know r. That's what we're looking for, times, and we have 35 for x. Okay, so this is where we're going to get from our 2 points, and this is, exponentially decayed, so that's the e to the rt in this case, because that's how we did it. Now the other one was exponential too, but this is exponentially, so that's going to be our key thing. So what do? Well, we need to solve for r. So first thing we need to do is get rid of that 100, so we'll divide by 100. So now what do we have? Well, we have 0.5 equals e to the r times 35, or 35r if you wanted to write it that way. Now, does anybody remember log and exponential functions? If we take the ln of this side, and we better remember to put the ln over here, we're going to be in trouble. If we take the ln of this, we get to bring down our exponent. So we can bring that down, and that's going to be r times 35 ln of v is equal to ln of 0.5. Okay, so that helps us simplify and get rid of the r, or get that rid of the r as an exponent and make it a number. Well, what do we know about ln of v? Well, guess what? That's equal to 1. And if you don't believe me, let's go over here and kind of do it in our calculator, because that's a good thing to practice. Ln of e, oops, not that one, ln of e to the 1, because it was just to the 1, is equal to what? 1. Okay, so that's nice function we use with ln's, and it makes it so we can bring down everything out front. Now we have r times 35, so let's get rid of 35. So we divide by 35. Now we have the ln of 0.5 to over 35. So we have the ln of 0.5 divided by 35. So that gives us that value. So let's write that down now. All right, so that was our r equals negative 0.0198. So that's our rate of decay. Okay. So can we get a value from that? Well, our equation? Sure. Now we have a of t, some future value of t, is equal to, well, we had 100 to start with, and we have an e to the negative 0.0198, and that's times t. Okay, so that's our function. We're happy now we have a function, and what do we do now? Well, now they want t is 54, so okay, well, we plug that in. And now we go back over to our calculator. All right, so we have 100 e to the negative 0.0198 times 54, and that gives us 34.33. We'll call it 33. So This gives us A 54 equals 34.33. What was their units? Milligrams of some radioactive substance. Okay. All right. So that's doing it exponentially. Now, you know what? Can we do this the other way we did it before with the B's and all that stuff? Yeah, we can. Let's do it and see if we get the same value. Okay, so I did it this way because we're working with the exponentials in the past couple, slides. We were doing e's and stuff. So that's why we did it that way to start with. Now, let's do it the other way. So now let's kind of block all of this off. And so now we have kind of the bottom half of the page to work with. All right, so we're going to use the same two, except now we're going to use a B instead of the E. So what does that give us? Well, that gives us 50 equals 100 B, and that's going to be to the 35, because now we don't have to do an R. We just have 50 equals 100 B to the 35 because our rate is included in the B now. Because remember, if we had 1.06, that's what B is equal to. And whereas here, this is E to the R, which is the 0.06. And so there's a little bit of difference on how these work. Okay. Now, here again, we're divide by 100. So we get 1/2 is equal to B to the 35th. Now, how do we simplify that? Well, we have to take that to the 1 over 35. So 1/2 to the 1 over 35. So 0.5 to the 1 divided by 35. Okay, so that's going to be 0.9804. So B, where's my cursor here? B is equal to 0.9804. Now again, we're rounding to 4 decimal places in most cases where we have that. So that says A of 54 is going to be equal to our a little a, 100, times B, which we just found is we'll put 0.9804. Okay. And that's going to be to the X, or in this case, 54. Okay, now what does that equal? Well, let's go check that out. So we're going to have 100 times our B, which was 0.9804. Now, if we would put all these, we'd probably be closer. So maybe let's just do some more decimal places. 3906099 to the 54. And we get 34.32. Okay, so what if we had done instead that 4, and now let's delete all of that. We got 34.34. So, going between those two differences, we can see that there's, a little bit of difference in that second decimal place. So with the 0.04, that was 34.34 milligrams. So that's what it would be if we did it with the B method. If we did it with the exponential method, we get this. Now, it looks like this one's a little shorter down here, but if they want it into the exponential format, we really have to do it the way we just did it up here, okay? So kind of depends. Both of them give us roughly the same answer, 34.33 over 34.34. So we get the right amount no matter how we do it. And so again, it's going to determine if some questions ask you to do it through the B method or if they want it through the E exponential method, okay? All right, so here we have Kayoko has $10,000 she wants to invest. Her bank has several investment accounts to choose from, all compounding daily. Her goal is to have $15,000 by the time she finishes graduate school in 6 years. To the nearest hundredth of a percent, what should her minimum annual interest rate be in order to reach her goal? Okay, well, this is our P. Her goal is 15,000, so that's A of, and that's in 6 years, so A of 6 is equal to this. This is our T. Compounding daily, that's going to be our N is equal to 365. And what we want to know is what will the interest rate be? Okay, So now if we wanted to write all that down, we could, but I kind of wrote it in here. And now what we're going to do is we're going to write out our kind of our function here. So we want our a of 6, which is 15,000, is going to be equal to initial value of 10,000 times 1 plus r over number of days, 365, raised to the 365 times t of 6. Now we have to solve for r. Okay, so like I said, we can solve for any of the values in here. This one had r before we found p, and the one before that we just found a. So it all depends on what you're doing here. All right, so what do we do? Well, we're going to divide first by 10,000. Okay, so we'll divide that by 10,000. And so if we do that, it looks like 1.5 is equal to 1 plus r over 365 to the 365 times 6. And I'm not going to go clear to my calculator to do that. I'm just going to do it on my hand one here. So 365 times 6, 2190. Okay, so that's 2190. Okay. All right. Now I need to get rid of that 2190. So how do I do that? Well, I'm going to take that whole thing to the 1 over 2190. So that means I have to take that to the 1 over 2190. Okay. Now I'm just going to leave that as 1 over 21 to 90 on the left. So that's going to be 1.5 to the 1 over 2190 equals, and all that cancels here. So I have 1 plus r over 365 now. Okay. Now I'm solving for r, so I'm going to have to get rid of 1. Have to get rid of 1. Now that gives me 1.5 to the 1 over 2190 minus 1 equals r over 365. Well, to solve for r, I'm going to have to multiply both sides by 365. So I'll have to multiply that whole thing by 365. And now I have to plug in this into my calculator. Okay, so let's go do that. So let's clear everything so we have a clear slate. So we're going to take 365 times, and we had the 1.5 to the 1 divided by 2190. Now this is where you need to remember to arrow down, and then we had minus 1 in parentheses, enter. So we need to get the 0.06758 as a decimal. So that's 0.06758. Now, if it wants it to be an interest rate, then that's going to be, move the decimal 2 places, 6.758%. Now, it doesn't say how many decimal places, but let's do 2. So 6.76% would be the rate that she would want to get to be able to reach her goal in those 6 years. Okay. All right, let's pause there and we'll be back.